Hello guys, welcome to today's video. In this video we're going to talk about the discontinuity of a function. In the last video we talked about the continuity of a function and we gave three conditions necessary for a function to be continuous. So for a function to be a discontinuous function, those three conditions need to fail. So therefore, if any of those three conditions fails, then the function is said to be discontinuous. And we have different types of discontinuity. But we're going to make use of the three important types of discontinuity, which is the jump discontinuity, the infinite discontinuity, and the removable discontinuity. So the first one we're going to talk about is the removable discontinuity. The removable discontinuity. Now, for a function to be a removable discontinuity, the first condition needs to fail. The first condition needs to fail for a function to be. The first and the second condition needs to fail for a function to be a removable discontinuity. Which is to say, the first condition for a function to be continuous is that f of a needs to be defined and the limit of f of x as x approaches a needs to exist. If those two functions fails, then that function is said to be a removable discontinuity. Let's take an example. Given a function f of x, which is equal to 5x squared plus 2x plus 1 at x is equals to 1. Now, let's solve for this using the three conditions necessary for the continuity of a function. So the first condition says f of a needs to exist, and at this point our a is 1, so we're going to say f of 1 rather. So whenever we see x equal 1, so we're going to have this. So we're going to have 5 plus 2 plus 1, which is going to give us 8. Now we're going to go into the second condition, which says the limit as x approaches 1, because our a is 1, of this function so we're going to use L'Hospital rule to look for the limit of this function, which is by differentiating. So differentiating this, we are going to have the limit as x approaches, so I'm going to have 10x plus 2. So putting 1 into this equation, we are going to have 10 to 1, so it's going to be 10 plus 2, which is equal to 12. So therefore, f of a is not equal to the limit of f of x as x approaches a. So therefore, this is an example of a removable discontinuity. So we are going to go into the second type of discontinuity, and we are going to talk about infinite discontinuity. Infinite discontinuity. A function is said to be an infinite discontinuity if the value of the function at x is equal to a tends to infinity. That's to say, the value of the function does not have a finite value. Which is, so when you solve for a function and the function doesn't have a finite value, which doesn't have a number like 1, 2, 3, that function is said to be an infinite discontinuity. So I'm going to take an example which involves an infinite discontinuity. So given a function f of x, which is equal to 1x squared at x is equal to 0. So using our direct substitution method, we can have, wherever we see x equals 0, so I'm going to have 1 to 0 square, which is going to give us 1 over 0. And when a number divides 0, the answer is infinity. So 1 divided by 0 is going to give what? Infinity. So therefore, this is an example of an infinite discontinuity because it doesn't have a finite value. So I'm going to go into the third type of discontinuity, which is the jump discontinuity. The jump discontinuity. In this type of discontinuity, the right hand limit is not equal to the left hand limit, which is to say, if we're given a function and that function involves two equations, if the left hand limit is not equal to the right hand limit, that function is said to be a jump discontinuous function. And how do we know which of them is the right hand limit and the left hand limit? The left hand limit usually carries a lesser than sign, while the right hand limit usually carries a greater than sign. So when you see those signs, you'll be able to know that, okay, this is the left hand limit and this is the right hand limit. So let's take an example involving jump discontinuity. So given a function So in this function, the right hand limit is x plus 2. The left hand limit is x plus 2, while the right hand limit is x squared minus x plus 2. So we're going to solve for f of a. So how do we solve for f of a? We know that they say that x is equal to what? Minus 1. So solving for f of a, which is same thing as f of minus 1, this is the first equation. We're going to have minus 1 plus 2, which is going to give us 1. So this is how we solve for the first one. So we have solved for f of a. Now we're going to continue. So we're going to solve for the right hand limits and the left hand limits. So we're going to start with the left hand limit. So solving for the left hand limits, which is the limit of x plus 2 as x approaches minus 1. In this case, we are going to have minus 1 plus 2, which is going to give us 1. Then, sorry for the right hand limit, which is the limit of x squared minus x plus 2 as x approaches minus 1. In this case, we are going to have minus 1 squared minus 1 plus 2. So we're going to have minus 1 squared minus 1 plus 2 is going to give us 1 minus 1 plus 2, which is 0 plus 2, which is equal to 2. So therefore, the limit as x approaches minus 1, x plus 2 is not equal to the limit, of as x approaches minus 1 of x squared minus x plus 2. So this is an example of a jump discontinuity. I hope this video is very helpful.